we're going to be bringing to the stage now Shane and Sean from Scale Computing. How are you guys today?
DVR, how's it going? Good afternoon.
Good afternoon. Shane, great to see you.
Good to see you as well.
I have had the privilege of working with Scale for a number of years now, and nothing but success stories. Cost alone is just one factor, ease of management and everything else. So I'm already doing your presentation. I am so stoked to hand it over to you guys. I'll let you go, but it's great to have you here, and I think we'll have some questions probably from the floor at the end of it.
Sounds good. Thank you so much, DVR, for the introduction. I think, like you said, that you kind of set the table, kind of did half my job for me already. But thank you to everyone who took the time to join the event today with ThinkConneX and for your interest in kind of going over the Scale Computing platform if you've not heard of us before. So my name is Sean Barry. I am the Territory Sales Manager for Canada for Scale Computing, and I'm located in Ontario. So I handle coast to coast, regardless of vertical or sector. Now, I promise I won't take more than 10 to 12 minutes of your time because I really want to spend the majority of the time we're here with Shane going through the demo. So this is the majority of the Canadian sales and channel team, the main contacts that you will be coming in contact with at Scale Computing, with myself being the primary point of contact. Now, all the faces that you see on screen here are located in Canada. We're born and bred north of the border. So myself and Arash Nadiri, my country manager, we're located in Ontario. My systems engineer, Shane Primo, is located just a hair north of Toronto in Northern Ontario. And then Christy Kanan, our new Canadian channel manager, is located in the Toronto area in Paris, Ontario. So there are a number of contacts as well in the US that support the Canadian team, but by and large, these are the folks that you'll be working with. So Scale is a company. Our founders were IT directors and IT managers who were tired of the complexity and of the traditional infrastructure. So they set out to create a radically simplified management platform with high availability built right in. So if you have looked at any kind of infrastructure or let's say virtualization solution in the past, you have likely come in contact with Scale Computing in some way, shape, or form. But the key things I want to note here on this slide is that we have been innovating in the HCI space for well over a decade. Scale is trusted and deployed globally across the world. We have very strategic partner alliances with many of the big dogs in the tech space. We have been granted 24 patents in technology that protect the innovation that we bring to the market and to the industry today. We are headquartered in Indianapolis, Indiana, in the US, which is where a lion's share of our organization sits. Most notably, our entire support team is out of Indianapolis, and that support level is 24 by 7 by 365 within an offshore any support, and it's 365 days a year. Our R&D and our engineers are located, are mostly located in San Francisco. So we are really able to leverage the best and brightest out of Silicon Valley for our product development. Now we adopted KVM as our hypervisor in 2010, and we've been baking it right into our product since 2012. And now Shane will expand on our hypervisor a little bit later. Our Net Promoter Score, and I'm always very proud of this when speaking with new contacts, our Net Promoter Score is the highest in the industry at 91. And a lot of that is due to the reliability and simplicity of our product, but also our world-class support team. So our support team is highly rated, highly reviewed, and everyone gets the same level of support no matter what hardware, how many clusters you have, where you're located, you all get the same level of support. So the key takeaway here is that we are a leader in this space, and we are a solid choice for the future of your IT infrastructure. Now, edge computing is described as a physical computing infrastructure intentionally located outside the four walls of the traditional data center. Now, edge deployments are storage and compute resources that can be placed exactly where they're needed. You can also run on a small or tiny hardware footprint form factor, and you also may need a higher degree of automation. The infrastructure at the edge collects, processes, and reduces vast quantities of data for a variety of industries and markets. And edge computing can also act as a bridge between on-premise infrastructure and cloud operations. So just a few, case studies or use cases with edge computing that I like to bring up are in the casino industry. Scale is actually deployed in Resorts World Las Vegas, where their 12,000 cameras are actually housed on the Scale platform. So any data that is collected on those cameras on their resort is housed in Scale infrastructure in their data center. Retail, we're in Save On Foods, which if you haven't heard of them before, they're a large Western Canadian grocery chain. And Scale is actually located in their data center as well as at the edge at their store locations. For maritime, a really neat one actually. We partner with Seaspan, which is the International Ocean Shipping Organization that has scaled Nook clusters actually installed on their individual shipping ships. So I think that's pretty cool. So key point here is that the opportunities to deploy Scale are endless. Now, depending on who you talk to in the industry, hyperconvergence is defined a little bit differently depending on who you talk to, but Scale defines hyperconvergence as combining all of the separate components of compute, storage, and the hypervisor, or your virtualization layer, into a single device, and it simplifies the old traditional architecture mess. Now, this is the trend today and is making things easier for IT staff at any given organization to manage. This means to you, no expensive VMware licensing fees or renewals or anything like that. No third-party software, basically. So our solution is a true HCI. Compute, storage, and the integrated KVM-based hypervisor, so there's no configuring a different layer that might provide different updates that might go wrong up and down the stack. So it's much more simple and efficient. So Scale computing is really the new way to virtualize. So as I mentioned earlier, our solution is a true all-in-one turnkey appliance that provides you the hardware and software needed to run your data center and edge deployments. Now, I'm going to say 95+% of our initial setups are done with remote assistance with our support team. That's how simple they are to deploy in minutes, whether you're adding a cluster or setting up on Scale for the first time. Now, I always joke because when Shane and I, when we go to conferences or when we go to trade shows together, I'm the sales guy, and I can confidently set up our HE150 test cluster up and running in no problem. On top of that, whether you're migrating your existing infrastructure to a new Scale cluster or creating new VMs on your existing interface, the overall process takes a matter of seconds. And things with built-in replication, scribe storage management, proactively failing drives and shipping you out new ones, et cetera, all of this allows your workloads to stay up and running with a self-healing platform. Now, Scale is actually the stack owner, regardless of the vendor of the chassis. We are the stack owner for all of the gear of the Scale cluster. So we take ownership for repairs and get anything that you need on the back end. We work with our vendors on the back end to get what you need to stay up and running with next day shipping on parts, replacement drives, et cetera, et cetera. Now, the Scale operating system, as I mentioned, and the hypervisor are included, so you need no third-party software to get your Scale cluster operational. And all of this reduces your overall total cost of ownership with not only the money that is invested in the Scale infrastructure, but in costly hypervisor purchasing or renewals elsewhere, but also in the manpower and the staffing that is needed to maintain the current setup. Now, the Scale computing platform, as I mentioned, combines everything you need. The HyperCore for virtualization, servers, storage, backup and disaster recovery, all under powerful fleet management called Fleet Manager, to deliver a single manageable solution for MSPs and for end users alike. So the Scale Computing HyperCore is the operating system that runs on premises. It is the HCI stack, an easy to deploy, fully integrated virtualization solution that provides high availability and redundancy. And on the Fleet Manager side of things, it is actually the industry's first cloud-based fleet management tool, allowing you to see all deployments and can manage them from one screen, one single pane of glass, and everything from production apps in the data center, VDI for remote workers, video surveillance, digital signage, et cetera, it is all right here to manage with your fingertips as one. And a new innovation to the Scale platform is zero-touch provisioning. So you can utilize ZTP to pre-configure hundreds or even thousands of sites in the cloud with Fleet Manager to automatically install in less than 20 minutes at the edge. And ZTP allows administrators to virtually configure clusters in Fleet Manager with cloud-like simplicity, decreasing installation time of nodes and clusters by up to 90%. And ZTP virtually eliminates the need for IT resources at the edge, significantly reduces the cost and lead time for adding replacement hardware at the edge, and allows organizations to deploy, pun intended, at scale. Now, this is a new, exciting success story that we worked with DVR to assist the Kingston Police Service with their IT challenges. And I'm happy to share the full story with anybody after our chat today. But the IT challenges that KPS were facing was they needed to ensure a 24/7 network and application availability to emergency 911 responders, police officers, and support staff. They needed to maximize resources with a small IT staff and limited budget. They needed to do more with less by reducing the complexity and the cost of their existing IT VMware infrastructure. And they needed to implement automated failover solutions to ensure critical systems remain up and running and operational during any kind of outage. And the results after installing Scale into their environment was the first, instant scalability. So KPS currently have over 100 VMs running on the platform, and they can spin up or tear down any VM in a matter of clicks. The second is automated redundancy. So data is protected with multiple layers of replication and data between two clusters in the infrastructure. Application availability. So highly available integrated solution that provides 24/7 reliability of mission-critical emergency 911 services. And I touched on this a little bit earlier, but high-touch customer service. So Scale Computing's knowledgeable and highly responsive technical support team is always just a phone call away, an email, a support tunnel in your existing cluster, ensuring that issues are addressed promptly and efficiently. Now, with that, I'm done talking. The moment of truth, the reason why we're here, let's get into the meat and potatoes of the Scale platform. I will pass it off to the brains behind the brawn, my systems engineer for Canada, Shane Fremo, to give you a sneak peek at the Scale Computing platform.
Awesome. Thanks, Sean. Thanks for the introduction as well. My name's Shane Fremo. Like Sean said, I'm a systems engineer for Scale Computing in Canada. I'm going to start off by kind of taking a quick walk through our Fleet Manager that Sean had already mentioned. So the idea with Fleet Manager is if you have, let's say, multiple deployments of Scale gear out in the world, it can be multiple locations. It could be, we have, like Sean mentioned, we have customers that have, smaller clusters deployed kind of all over the country, or in some cases out at sea, whatever it might be. The idea with Fleet Manager is being able to log into a cloud-based management tool and being able to see all of your deployments in one place. So I've logged in already, and you can see that currently I'm looking at managing about 28 systems total. So that's 28 deployments of Scale currently that I can see the status of. We kind of break that down in a nice little pie chart here. So quickly when you log in, you can kind of see the health of all of your deployments and kind of where everything is at as far as if there's any statuses, if there's any, anything critical going on. At a quick glance, you'll be able to see where that's coming from and exactly what's going on. We also show over here, again, this being a demo environment, it's actually a good representation because there's, and we've had updates come out in the last little while. So some clusters are on all kinds of different versions of our software currently. Good to see, again, at a glance, what version you're running on. Obviously, like everybody else out there, we want you running on the latest and greatest. And once I get into the demo here a little bit, I'll show you how easy it is to actually keep a Scale cluster up to date. Then down here, we have those conditions kind of presented to you with the most critical ones first. So I can see I have a couple clusters currently that maybe they've had a failed drive or something that I need to investigate a little bit further. The clusters themselves also can send out alerts directly if you have, through email, or if you have some kind of syslog server or something like that, we're able to send alerts through those as well. This is just another kind of collection point for those different alerts. If I click on clusters here, this is where I'll see, it's going to refresh my page here. This is where I'll see a breakdown of all of my clusters that I'm currently managing. And again, I have them sorted by health. You can see, a chunk of them are healthy. I have a bunch that are disconnected because those clusters they just haven't phoned home in a period of time. But I can see what each cluster is doing. So I can see, this US prod cluster here. It's a 3-node cluster, which is our traditional configuration for something that's highly available. And I'll get into that a little bit more as we continue on as well. And then I can see at a glance, how many VMs I have running. That's this first number, 21. And then how many VMs I have in the cluster total, in this case, which is 52. We have some tagging as well, just a way to kind of group and organize. Again, when you could have 1,000 clusters in here. So, you want some level of organization to maybe make it a little bit easier if you're searching for a specific one that you want to look at. And then all these metrics over here, as far as percentage of resources being used, this is at the cluster level. So I can see how much storage I'm using, how much RAM, and then also how much processing power I'm using. And then you can see down here, I have quite a few of these little blue clouds, which means that those clusters specifically have updates available currently. So like I mentioned, we had some new ones released this week. So lots of these have updates available. If I click on one of these right now, I get a little bit, I can look at this is the cluster that I'm looking at, the current version that it's running of our software. And then I can click on this little arrow here and get a breakdown of the release notes for that update, and gives me an idea of, about how long the update's going to take once it starts. So the idea here is that, again, if I'm managing multiple deployments out wherever they might be, again, it could be several locations within the same city, or it could be spread across the country. It doesn't matter. I can actually kick an update off right from here. And when I do that, I can click this, and then what will happen is the cluster will actually download the update automatically once I kick this off. And then I'm actually going to flip over to cluster I actually have running right behind me. And I've already done an update on here, so I don't have one available. But as that update would apply, you can see here I'm looking at a 3-node cluster. So that's what each of these little rectangles represents. And I have virtual machines running on each one of them. Now, I mentioned, and Sean mentioned as well, that we have highly available clusters. So what that means is we protect against drive failures, and then we, of course, protect against what we would call a node failure. So if one of these nodes was to go offline, there's enough resources in this cluster to run all of my virtual machines on 2 nodes in that scenario. We leverage that in order to do a update to the system without you having to have a huge maintenance window, for instance. So when I click that update button, if it's here on the cluster locally, or if it's up in Fleet Manager like I was just showing, this cluster will then start to download the update, the first node. Then it's going to do what's called live migrate these 2 virtual machines over to the other nodes in the cluster. And live migration, if you're familiar with other products that are out there, like I'll use VMware as an example. They have vMotion. It's similar to that, where the virtual machine will actually just move over and run on one of the other nodes in the cluster, and users have no idea that's happening. And then that node, once it's free of all of its virtual machines, that update will then apply. And if a reboot is required, which depending on the type of update, it may need to reboot the node, we may not. At that point, the node will reboot and it comes back online. Now, I like to point out that this whole process, all I've had to do is click one button to apply it, and then you're hands off from that point. The system takes over and runs through the update process on its own. So if I was looking at this screen and I clicked apply update, I would get locked out of this view for a period of time, so I could just see the status of the update as it completes, just so I'm not going in here as the person managing it and making changes while the update's going through. So that would happen, that update would apply, that node would reboot, and then our automation that's in the back end will take over and make sure that the update applied correctly and that node is healthy and it's ready to have its virtual machines migrated back onto it. So that's what would happen. That node would be complete. And then this next one, let's say this middle one here, it's going to go through that exact same process. So download the update, migrate the VMs off, migrate them off, and apply, reboot, all of that. And it's going to do one node at a time until all the nodes in the cluster are updated with the latest version of our software. Now, you also don't have to worry about underlying firmware versions when you apply these updates. So the other nice thing is if you see the updates available, you don't have any other heavy lifting to do to get it applied. You literally can just click the button and have the system take over for you and apply everything. So that's making updating clusters basically as easy as we possibly could. You can even phone into our support, and they have the ability, if I go into the settings here on my cluster, and there's this remote support tab, they actually have the ability with your permission to connect in securely through a secure tunnel. They would give you a code like I have here, and you open that connection to one of our technicians, and then they can get into the back end of the cluster. And if you said, hey, I want you to check it out, make sure everything's healthy before we kick this update off, have them kick the update off and monitor it for you so that you're, if it's the first time doing it, you have a little bit of help from our support team if necessary. 99% of the time, everything goes off without a hitch, and you're updated within, that this little blurb here said it could take 20 to 40 minutes to complete. So a pretty quick process. Again, you don't have to set a big maintenance window with your users. We actually recommend that you do them during the day because you can get a hold of our support team quickly if necessary. Everybody is available and in the office during normal working hours. We have 24/7 support as well to cover you off if you do decide to do it off hours, but in this case, you don't have to. So with Fleet Manager as well, of course, you can kick the updates off. If I click into my cluster here, this is the one we were just looking at, I get a little bit more information. Again, this is all being pushed up from my cluster into here. As you can see, this checked in a few seconds ago, so it's pretty close to real-time information that you're getting up here. I can see each node individually. The ones that I'm looking at were our Intel NUC-based chassis, so they're our smallest highly available cluster that we can deploy. We can get a lot larger. Of course, we have 1U rack mount servers, 2U, big, deep on storage, lots of processing power, lots of memory. But these Intel NUCs are also very powerful and kind of fit different needs depending on what you want to run. So that's what I have here sitting in my office. So I can see, there's single drive units. We use NVMe drives in these guys. Single CPUs, they have either like an i5 or an i7 processor in them. These have 4-core i5s. And then I can see what my usage is like across each node in the cluster. Below that, I get a breakdown of all of my virtual machines. So I can see the status of them if they're on, my description that I've applied to them, as well as any tagging that I've done. If they're pulling an IP address, I can see what that is here as well. Now, there's two other kind of interesting things that you can do from within Fleet Manager. So I showed you the local UI where I'm logged into one of my nodes in the cluster directly. This is this IP right here. That's on my local network, excuse me. But let's say I'm off my local network. I'm away from my house or my office, whatever it might be, and I need to manage my cluster. So you can see up here, I have this go to cluster button. I can click on that right now, and this is going to open a secure tunnel to my cluster. I'm already logged in, so it took me right in. But normally what would happen is I would get a login page, re-authenticate with my cluster. All the authentication I've set up locally is still there. And now I'm actually into my my management interface of my cluster, so I can do what I need to do in here. And you can see my URL up here is a little bit different. It's kind of encrypted in a way. This is because what's happened is Fleet Manager has asked my cluster to open that secure tunnel. That's exactly what we've done. And that's encrypted as well. So the cluster is actually initiating the connection into Fleet Manager to allow me to come in here and manage the cluster. So you can, again, you can imagine if you have deployments, again, across maybe the country or even, in several different locations, you don't have to worry about having site-to-site VPNs set up to manage your deployments. You can use Fleet Manager to get you in via what we call Secure Link, which is what I just used. And then I'm able to get in here and do my day-to-day. The other piece of the puzzle to this now is my actual VMs themselves. So if I look at one of these, let me pull up, it could be this guy here. So I can actually open, again, this is through Secure Link. I can open a console view to a specific virtual machine directly from Fleet Manager. So you can see I actually have a Windows 11 workstation running here, and I've connected directly into our console view that we have. If I was to do that in my local cluster here, it would look exactly the same. So this is me on the local, and if I open up one of these guys here, there you go, I get the same view. So no matter where you are, you're able to manage it on basically any device, because both Fleet Manager and our management on the actual cluster itself is all HTML5. So any modern browser, you're going to get the same experience. And if you have a login to Fleet Manager, you could be on basically any device, log in, could be a phone even, and start managing your cluster remotely that way. All right, so that's basically what Fleet Manager does. Sean talked about zero-touch provisioning. That's part of Fleet Manager as well. That all gets set up in Fleet Manager. But I'm going to focus a little bit more on what you're looking at here with the cluster and kind of what's going on, so you can get an idea of how this all works. So across the top, this is the same kind of percentages that we've seen in Fleet Manager as far as what I'm using for CPU, RAM, and storage. And this is at the cluster level again. So I have 12 cores in my cluster, because I have 3 i5 4-core processors in these Intel NUCs. And then I have 92.6 gigs of RAM. And I have here, this says I have 1.4 terabytes. That's raw storage in the cluster. And the way storage works in a scale cluster is we mimic a RAID 10, where your data is replicated, like mirrored and striped within the cluster. So what that means is, because we have our own block-based storage system that Scale has developed, each block of data is guaranteed to be in 2 physically separate locations at any given time. So what that means for you is, on the storage end, when I have 1.4 terabytes of raw storage, I'm going to get about half of that as usable storage, because every block of data is replicated, so it's protected. So that cuts that about in half. But what that means is this VM that's running here on this first node could be accessing data on that node or the other 2 nodes in the cluster. We basically take the storage and make it all one big pool of storage that's then, like I said, replicated. In these nodes, it's a little bit different because they're single drive units. Again, when we get into multiple drive chassis, so our typical data center deployments that could be a single SSD and 3 spinning drives. In those types of deployments, in a 3-node cluster like this, you could suffer multiple drive failures and you'd still be up and running. So in that scenario, if you had a drive failure, what happens is you'll obviously get a notification that something's happened, that a drive has failed. we're able to, through our support, you would contact them and say, hey, I had, this alert. They can check it out and say, yeah, a drive did fail. We're going to send one out to you next business day in the mail. And all you have to do is hot swap that drive out, take the dead one out, put the new one in, and then off you go. So what happened when that drive failed is the cluster, again, there's a lot of automation in the back end. It actually made sure whatever data was on that drive was replicated still within the cluster. So we knew there was one good copy of all the data that was there. And the system just makes sure that there's 2 copies of it again. So when that drive goes into the cluster, once you replace it, it just sees it as available storage. So there's no big RAID rebuild process that some people may be used to with other systems like a typical NAS or SAN type of storage, where you have big RAIDs where you have to do a RAID rebuild or you have to have a hot spare. We don't do that. We protect the data, make sure it continues to be protected when that drive fails, and then we will actually once that new drive comes in, the system just sees it as available storage and just starts filling it up again. So there's no big IO intensive process that could kick out another drive. But let's say another drive did fail after the first one. Again, in a typical data center deployment, you could lose a full node's worth of drives and you'd still be up and running. We protect against an entire node going offline. And what happens in that scenario, if this node was to go offline, is, and let's say, could be somebody pulls the cables out of it, these Intel NUCs, somebody comes by and just pulls the power on it by accident. The system will automatically recover from that. It will notice this node has gone offline, and it will actually restart these virtual machines on these other nodes in the cluster. So we will, and then at that point, you can do you phone our support again and say, hey, what's going on with this node? And you could get if we have to send out a full replacement node, a full chassis, we send that out next business day as well. You swap out the hard drives, cable it up, connect it up, and away you go. Now from there, I think we still got a little bit of time. So I will just quickly talk about what the individual VMs look like, how easy it is to create a VM, and how the VMs are kind of organized. So I can see how the virtual disks and all that kind of thing are organized here. So we have VM cards. They follow the same kind of gas gauge style like we have up here, where you can see how much CPU power you're using, what the IOPS are, disk usage, all that kind of good stuff. If I click into settings, you'll see underneath, I've provisioned 2 cores and 8 gigs of RAM for this, and I have 1 virtual disk here. If I click on that, I can see a little bit more information, and I can actually expand a volume on the fly as well. So let's say I needed to extend this a little bit, I could do that on the fly, and then go into, let's say if it's a Windows-based VM, I could go in and actually go into disk management and extend my partition without having to reboot the VM. The other thing here is snapshots. So I'm going to go down quickly to one of these guys here, and you'll see there's 9 snapshots on this. So we have built-in snapshotting and replication. And what that means is we can have schedules in the cluster for how often you want to take snapshots of your virtual machines. And that's your quick recovery tool. The nice thing with how we do snapshots on a scale computing cluster is we take just the metadata changes between snapshots. So you could have 1,000 snapshots on a VM, and there's no performance penalty. It's just gonna, as you can see here, it's gonna take up a little bit of storage, but as far as the performance of the VM, you could have 1,000 or more snapshots on there, and it's not gonna have any effect on the performance of the VM. The replication part comes in if you deploy another scaled node or cluster at another location. You could actually set up replication from one to the other. And what that means is if I go in here, you're gonna see this remote clusters area, I can simply add another cluster in via an IP and a login, As long as you have a site-to-site VPN with certain ports open, you can initiate that connection. And then my virtual machines, you see the setup connection would actually be setup replication. And then I would have a drop down where I can select, I could select where I want to replicate to. So if I have another node or I have a bunch of them connected, and I just pick what I want. And then every time a snapshot's taken locally, it's then sent over to the remote location as well, replicated over there. And then it would sit there powered off, ready to be spun up at a moment's notice. So basically you could spin up a clone and be up and running. If something happened in this production environment, let's say a fire or a flood, you are protected in that scenario where you could spin up workloads in a DR environment. Now, creating a VM, super easy. Hit the plus sign, give it a name. Today is what, October 6th. As an example, I'm going to call this a demo, and I'm going to tag it as demo as well. And I can say, pick my OS, we're KVM, and Linux under the hood. So we're basically just asking, hey, are you putting a Windows VM or a Linux? The reason for that is we'll attach what we call our Scale Tools ISO with some drivers required to install with Windows, just to make everything seamless. Drivers recommend performance unless otherwise maybe support's asked you for compatibility reasons to use other drivers. Boot type, you can pick whatever one you want here. If you want standard BIOS or UEFI, you can do that. And then I can tell it how many CPUs, how much RAM, and I can create up to 3 virtual disks here on the fly. And I can also pick what I want to boot off of. So I have a version of Windows Server here that I've uploaded to the cluster. There's an area where you can upload an installation ISOs, and then you can simply click create. And what will happen is I will have this powered off VM right here that I can simply turn on. And if I go to the console view here, I'm going to be able to see this booting up. So what happens when I created that and I attach my ISO is, because it's Windows, we mount the Scale Tools ISO automatically, and then also the installation ISO is mounted and booted off of automatically. So you can see it's already booting off of it here. And then I could go through my regular, setting up the operating system and all of that, and away I go. So that's kind of the long way of going. The short way would be to have a VM powered off as like a template. It could be a sysprep machine or something to that effect. And then I can simply come in and just hit this little button here, which is clone, and clone out a copy. I've cloned this guy once, so this will be clone, but I simply can click clone again. And shortly here, I'm going to have another copy of this VM ready to go, and I could simply power that on, and away I go. So that's how quickly I could spin up a new virtual machine in this environment. Now, another thing with the snapshotting, which I will show, is you can take this little camera that you may notice here. That's a manual snapshot. So let's say I'm doing an update to this particular VM. I can take a manual snapshot before I do the update, let that run. And then if I go into my snapshots, there it is. I could clone out from that snapshot. So that's how you roll back, is cloning from a specific point in time. So that's super easy. But also what's captured is the virtual disk that's part of that VM as well. So what that means is you can actually do a file level recovery directly on the cluster from a snapshot. So let's say you're doing snapshots every hour. Maybe you have I hope you have traditional backups still configured, but they're off-site. It's going to take a long time to pull data back. Maybe you can go into your snapshot and actually do a file level recovery and get that file that was deleted back. So you can come in here. I can mount this copy of the virtual disk back to the same virtual machine it came from, which is this Ansible one in this case. Or if I click that little drop down, this is all my VMs in the cluster. So I could pick any VM I want, and I could actually mount that virtual disk from that point in time. So very powerful. Again, quick recovery, file level recovery if needed, built in. One thing I didn't mention while going through all these different features is everything you see here today is one level of licensing to get support and licensing to get access to it all. We don't have different tiers of licensing or anything like that. So all the features you've seen, if you deploy Scale today, you're going to get access to all of those. And then as long as you have an up-to-date support on a cluster, you'll get access to any new features that come out as they do as well. So there's been quite a few. One of the later ones that I kind of glossed over when I was creating a VM is you'll see this VTPM. It's under experimental currently. That is for Windows 11 support because it requires TPM as part of it. So that's a new feature that's being rolled out so that you can have Windows 11 VMs on the cluster. We're also very soon going to have the ability to upload VMDK or VHDX files directly to the cluster as well. So you can see this is where my ISOs live. And I also have an uploaded virtual disk area where I can take those files, I can upload them into my cluster. And then I can actually, when I'm looking at a VM, if I'm looking at the disks here, if I want to add a disk, I'll have the ability to pick one from my uploaded virtual disk. I don't have any currently, so I can't pick one, but if I did, I'd be able to pick it out of this list, hit create, and it will actually convert it to a format that our cluster can recognize, and then it will attach it to that virtual machine. So it's another way to get, potentially if you have appliance VMs or if you're coming from another environment and you just want to export a VM out and bring it into the cluster, it's just making that a lot easier. All right. That's it for me. I guess we can go now if there's any questions at all.
Yeah, thanks, Shane. So we obviously will leave the floor open for questions, but I just wanted to put my contact information here. So go ahead and scan the QR code on the screen that you see so that, like I said, if you do have any questions that come up after the event today, you have a link to all my contact information. So Shane and I wanted to say thanks to DVR for having us here, and we'll open the floor to any questions.
Thank you, guys. Always a stellar presentation. I mean, I'm always a student of Scale and continuing to learn. We did have a couple of questions, I think, that bring some really good points to the table. Could you highlight or emphasize how Scale reduces RPO and RTO?
Sure. So through snapshotting that I was just showing, I mean, that's basically exactly what that tool exists for, is to be that quick recovery tool. You can be as aggressive as you want with snapshotting. You can do 50-minute snapshots. It just is a matter of having enough storage in the cluster. And then with our built-in replication, so that's just on the local cluster, you can have the snapshotting so you can quickly recover, right? But also having a DR node or cluster that you replicate to, now you're protected against other failures that could happen if, that whole cluster goes down, that kind of thing. And then, of course, with everything being highly available, you're protected against drive failures, all that kind of, we have multiple power supplies to protect the hardware and all that kind of thing too. So that all kind of couples together really good. RPO and RTO, like you can get that almost as low as you want.
Excellent. One of the questions certainly is from some of the other platforms that are out there. What does a migration look like from, say, a VMware platform?
So a couple ways. The one I mentioned now with being able to upload VMDKs directly is one route. We have a foreign VM import process currently as well, which is a little bit more manual of a process if you're okay with a little bit more downtime. But then the one that we use the most is we leverage Carbonite Migrate as a software to help us migrate from your current environment. And that could be VMware, that could be Hyper-V, that could be a physical workload. We can migrate that directly into Scale and cut it over. Once it's set up, it could be 10 to 15 minutes to cut a virtual machine over.
Right, absolutely. And to your point, it was Scale who introduced us at Connex to the Carbonite team, and really the value that extends from that as a complementary platform is outstanding in combination with Scale. So it makes that customer life much easier. I think the elephant in the room is our last question. I think I think, Sean, you know where I'm going with this one.
Yeah, no, 100%. In terms, I guess, of, why scale over, let's say, Nutanix.
Absolutely.
Yeah. Okay. So first and foremost, I kind of alluded to a couple of these points before, but first and foremost, there's no third-party software, right? So a lot of the times with the Nutanix deployments, they come equipped with all the hardware needed and everything like that. But and aside from maybe like a very, very simple hypervisor that they do bake in, a lot of the times in a majority of deployments that I've seen when speaking to VMware customers is they do add that extra layer, right? So as just a little bit of extra complexity to manage. Aside from that, our support is second to none. I stand by my support team 110%. The average vendor with next or behind, or the average vendor within our industry is at around an NPS of 65 to 70, and we're at a 91. And like I said, aside from that, Nutanix uses the VSA model, or the virtual storage appliance model. We use Scribe, and what that means to the end user is we are using a lot less in terms of resources to power workloads and get them to run. So we use a fraction of a core, 4 gigs of RAM, just to power us on. Whereas with the VSA model, you can use even 3 or 4 times that. And as the end user, they are the ones that are actually funding that overhead.
Right. And absolutely. How many times have we worked with customers leveraging Live Optics and presenting those statistics back to the customer and showing them the literally the overhead that some of these other platforms like Nutanix demand, almost to the point where it's a strong percentage of a whole nother node. It could be 20 or 30 or 35 to 40% of another node just to carry it, based on the fact that they leverage CVM.
Right.
My NUC cluster
Absolutely.
I showed can't exist in Nutanix currently because they just can't get that small. So
there's a great example where that just elevates the cost for the customer, because they have to buy additional resources, additional RAM, additional CPU to carry this load for those things, for the CVMs buried within Nutanix, as an example.
Correct.
Absolutely.
Yeah, exactly. And everything like that, we just provide simplicity of operations, allowing the customer to focus on more strategic projects, right? So,
absolutely. Guys, I cannot thank you enough for today. Fantastic as always. Always great to work with Scale. The entire team is amazing. We're coming down to see you in April down in Vegas. Is going to be an absolutely fantastic show. And we're looking to take one of our customers with us to Vegas. So it's going to be a great event.
Bring as many
even better than last year.
What's that saying? What happens in Vegas stays in Vegas? Something
I think
like
that's still their motto, isn't it?
DVR, I've never heard of that before.
Never heard of that before. Guys, thank you so very, very much.
Yeah, DVR, thanks so much. It was a pleasure. Thank you so much for having us, and thank you everyone for your attention today. We appreciate it.
Thank you.